distributed, and again, normally distributed meaning it's a bell-shaped curve, right? Would the SAT have the mean score of 1497, same score like before, the standard deviation of 347? And the ACT have the mean score of 21 and the standard deviation of 5, right? And again, as you can see, the ACT is only 36 is the highest, right? So again, the number is smaller. So they ask you who have a better score, the 2150 on the SAT or a 30 on the ACT, right? Look at this thing here, ACT and SAT have a different scoring system, right? So how can we take the 2550 and compare to the 30 because they have two different subjects, two different methods to score you guys. How do we know which one is better, right? So that's the unique thing about the Z-score is the Z-score is a standard normal, a standardized number, right? The bigger the Z-score, the further away from mean, the better you are, right? The smaller the Z-score, the negative Z-score, meaning the worse you get, right? So looking at this thing here, to do this thing here, the first thing we need to do is we need to find a Z-score for both items. We need to find a Z-score for the SAT and the Z-score for the ACT. And the SAT Z-score is, do you agree that the SAT, the data is 2150 minus the mean of 1498 divided by 347. That's my SAT data. Everybody agree that SAT is 2150, that's my data. The mean is 1498 divided by 347, which is the Z-score is 1.88, okay? And then we need to find the ACT Z-score. And the ACT Z-score, which is, again, as you can see, we take the 30 minus the 21 divided by 5, which is the standard deviation, which is 30 minus 21 will give you 9. 9 divided by 5 to give you 1.8, right? So looking at this thing here, as you can see, again, the two scores are very good, right? I mean, individually, the Z-score, the score are very good, right? 30 on the ACT and 2150 on the SAT, that's very high, right? But how good is that? Again, as you can see, among the SAT student, among the SAT people, this person scored 1.88 standard deviation, right? And again, meaning again, the ACT is only 1.80, which is the bigger the Z-score, the better the actual score, right? So as you can see, the Z-score for SAT is higher, so the SAT score have a better value in terms of that, okay? So again, and that's one thing about the Z-score is you know, if you took my statistic, I asked you, is LeBron James taller or am I taller than LeBron James, right? And you're probably laughing right now and you say, well, LeBron James probably will be very tall, right? I mean, relatively to their group, right? Meaning if you take off the average of the NBA player, right, and the standard deviation of the NBA player, LeBron James compared to the NBA player is not taller than me compared to the Asian height, right? So again, relatively to our group, I'm taller than LeBron James. Obviously, LeBron James is taller than me, right? But relatively to the group, I'm taller, right? So again, in a sense, that's what statistic is, right? We try and make a number and state. But before we continue, let me ask you guys a question on how to find a Z-score. Question on how to find a Z-score and why. We haven't seen the Y yet. You will see the Y of the Z-score in a bit, but question on how. The how to find a Z-score. All right. If you don't have a question, let's take a look at the why, right? Why do we find a Z-score? Because, ladies and gentlemen, this is what we have. And again, the book have a little bit different. This is the table that you will be using and I think this is the table that on the final exam they will give it to you guys, which is this is your standard normal distribution table. Okay, and on this table you will see the 4 column, right? You will see the 4 chart, right? And what is the information on this column? On this column, they give you this information here, which is, again, they give you the z-score and the corresponding area relate to that z-score, right? Excuse me. They give you the z-score right here. If you look at this thing here, this is your z-score. And again, this z-score is a little bit, it's only go by 10. And again, the good thing is whatever question they ask you on the final exam is within this table. Okay. So again, so this is what they have is they give you the z-score and they give you the area. One thing about this thing here is the area to the left of the z-score, meaning from the left to the given z-score. Okay. So again, this is what we have is, again, for instance, this is my normal distribution graph, right? My normal distribution graph is here, right? Apologize for all that mess. I tried to clean it up, but it's so as I clean up, it's get worse and worse. But anyway, let's take a look at this thing here, which is, again, we will do a lot of this next time, right? We will do a lot of this here next time, which is if I give you this table and I ask you, I want to know what is the percentage of the data, or what is the area underneath this curve from this left-hand side all the way to the z-score of 0.85. Remember last time I told you that the empirical rule, you can only jump 1 up, 1 down, 2 up, 2 down, 3 up, 3 down, right? This thing here, you cannot use the empirical rule for this, right? Empirical rule is only within 1, within 2, within 3, right? So how do we find the area underneath the curve corresponding to the z-score from the left-hand side to that given z-score? So this is what we need to do is, first of all, we got the z-score, right? All we need to do is, well, this is my z-score, and now this is the corresponding area to the left of the z-score. As you can see, to the left from here to here, that will be 80.23, right? Or 8.8023, which is, again, if you move the decimal place, which is, again, there are 80.23% of the data from the left-hand side to the given z-score. Okay, so that's what we have here, ladies and gentlemen, which is, again, this thing here, like I mentioned, the empirical rule are very, very limited. It's limited in terms that you have to go up 1, down 1, up 2, down 2, up 3, down 3, right? Now we have this a little bit better in terms that we can find whatever area we want to, right? We can, this chart will tell us, or we can use this chart to find whatever the position of your z-score is. And again, that's our goal, is we need to find the area underneath the curve. Okay, and again, we will do a lot of that next time. Today my goal was to hopefully you guys can see or understand the empirical rule, and then again, we will do a lot of calculation, a lot of find the area underneath the curve next time using this standard normal distribution table. And then from there, we will translate from 11.6. How do we translate that to 11.7? 11.7 is not hard. It's just like 11.6, but you have to do one extra step, which is you have to find a z-score. Okay. So again, question with this standard normal distribution table. And again, this is what we need to do, or why we need to find a z-score, because on this table, they only give you the z-score. Without a z-score, we cannot find the area, right? Our goal will be the area or the percentage, okay? The area is the percentage, ladies and gentlemen.